Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is June 2018, Paper 3, Higher Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome along to June 2018 Paper 3 Higher Tier Walkthrough. Question 1. Circle the decimal that is closest in value to 11/20. Okay, so I've got a fraction, I want to compare it with some decimals. Let's turn it into a decimal to start with. This is the calculated paper, so you can just type it into your calculator, 11 divided by 20, and then press the symbolic to decimal number. We can see that is 0.55. Okay, now which one is closest to 0.55? I've got 0.56, that looks pretty close. I've got 0.6, which is the same thing as 0.60. 0.525 and 0.5. I think it's that one there, isn't it? 0.56. Question 2. Circle the list of all integers that satisfy -2 is less than x, which is less than or equal to 4. Okay, so our value of x lies between -2 and 4. It can equal 4, but it can't equal -2. So it's going to include the numbers -1, 0, 1, 2, 3, and 4. Which one's that? It's that one there, isn't it? Question 3. Circle the largest number. 3.27 with a dot on the top, 3.27, 3.277, and 3.207. Well, this little dot on the top is the recurring decimal, isn't it? So actually this one is 3.2777 and so on, which is going to be bigger than 3.27, so it's not that one. And it's going to be bigger than 3.277, so it's not going to be that one, and it's also bigger than that one. Okay, yep, so that is our biggest one. Question 4. What is the size of the exterior angle of a regular decagon? Circle your answer. Now, if you remember the exterior angle, if you've got the various sides of your polygon and so on, carries on, then these ones on the inside are your interior angles. And these angles between, you have to imagine extending the line out of the side of the polygon. The angle between that line and the next line is your exterior angle. That's your exterior angle there. And there's a formula for finding it. The exterior angle in a regular polygon is just 360 degrees divided by the number of sides. So a decagon has got 10 sides, isn't it? Okay, so dividing 360 by 10 is going to give me 36. So it's that one there. Question 5. A is a common factor of 72 and 120, and B is a common factor of 6 and 9. Work out the highest possible value of A over B. Okay, So this fraction is going to be its biggest when a is at its maximum value and b is at its minimum value, isn't it? Okay, you'll get a bigger number if you divide a fraction by a smaller denominator. So let's take b to start with then. I think that one's going to be easier. A common multiple of 6 and 9. If we want b to be minimum, we're actually asking for the lowest common multiple of 6 and 9. Okay, so let's think about the multiples of 6 and 9. The multiples of 6 are 6, 12, 18, and so on. And 9 is 9, 18, 27, and so on. So you can see we found our lowest common multiple already. 18 is there, 18 is there, so our LCM then of those two numbers is 18. So that's going to be my value of b. What about a then? We've got a is a common factor of 72 and 120. So let's list out the factors of 72 and 120. I tend to write them down in factor pairs. So 1 goes with 72. 2 goes with, well, half of 72 is 36. I think 3 must go into it then as well. So 3 and 24, is that? 3 and 24. 4 and what? 4 and, that's got to be 18, isn't it? 5, no, 6. Yeah, 6 goes into it. 6 and 12. 7, no, 8, yes. 8 goes with 9. And look, I've met myself coming down the other way, so that's as far as I'm going to get. So quite a lot of factor pairs of 72. What about 120? We're going to have so many. So I've got 1 and 120. 2 and 60. 3 goes with 40. 4, yes, goes with 30. 5 goes with 24. 6 goes with 20. Also got a lot of factors. 7, no. 8, yes. 8 goes with 15. 9, nope. 10, yes. 10 goes with 12. And then I've got 11 in between. That's not going to be a factor. So that's all of them. Gosh, lots of factors for both of those numbers. So we want the HCF then of those two numbers. So we want a to be as big as it can be. So it's going to be the highest common factor of those two. So looking through my list, 72, no, 36 is my next biggest. That isn't on my list. 24, yeah, that's on my list. So look, 24 there, 24 there. So the HCF of these two numbers is 24. Okay, so what's the highest possible value of a over b then? Is going to be, so that was my a value, wasn't it? 24, and b is 18. So my highest value is going to be 24 over 18. Okay. Which I could cancel down, but I'm not sure I need to. So it could simplify to 4/3. Also an acceptable answer. Question 6. A and B are similar shapes. B is an enlargement of A with a scale factor of 1.5. Work out the values of X, H, and W. Okay, so first off, I've got X. Now that is the angle at the tip of my chevron. If two shapes are similar, then all the angles are going to be the same. So that's going to be just the same as 54, isn't it? So I'm going to say that X is equal to 54 degrees. Okay, now my 5 centimeter one matches up with my H, and our scale factor we're told is 1.5. So then H is going to be 5 times 1.5, which is 7.5 centimeters. Okay, and then finally, what have I got? I've got W here and 9 here. So if I timesed W by 1.5, I'd get 9. So then W is going to be 9 divided by 1.5, isn't it? So W equals 9 divided by 1.5. Okay, can you do that in your head? I can, but just in case you can't, let's just tap it into the calculator. 9 divided by 1.5 is 6. Okay, so I've got x is 54 degrees, h is 7.5 centimeters, and w is 6 centimeters. Question 7. Investment A. Save £150 per month for 2 years. 2.5% interest is added to the total amount saved. Or we've got investment B. Invest £3,500. Compound interest is added at 3% per year. After 2 years, how much more is investment B worth than investment A? Okay, let's start with investment B then. Save £150 per month for 2 years, and 2.5% interest is added to the total amount saved. So if we're saving £150 per month for 2 years, then we've got 150 times 2 lots of 12 months, which is 24 months. What's that then? So 150 times 24, that comes out to be £3,600. Okay, slightly more than the investment B. And then 2.5% interest is added to the total amount saved. So using our final original multiplier triangle, we want to know our final amount, and that is going to be, well, if I put my thumb on F, then I can see it's original times multiplier. Okay, so F here is what we're trying to find. O is the original amount, which is 3,600. And the M, the multiplier, is a 2.5% increase, isn't it? So it's 102.5%, which as a multiplier is 1.025. So my amount then is going to be 3,600, my original, times my 1.025. And that is equal to times 1.025, that's 3,690. Sorry, that was investment A up there, wasn't it? I'm doing investment B now. I'll get it the right way around. So that was investment A, and now I'm doing investment B. So investment B is invest £3,500 compound interest at 3% per year. So again, using my triangle, F is equal to the amount I'm trying to find. The original this time is 3,500, and the multiplier is an increase of 3%, so that's 103% as a percentage increase, which is 1.03 as a multiplier. So then my final, this again is going to be my original times my multiplier. But because it is compound interest, I'm going to raise that to the power of the number of years that we're going to do it for. So that's going to be 3,500 times my 1.03 raised to the power of 2. Okay, tapping that into the calculator. 3,500 times 1.03 squared, which comes out to 3,713.15. 3713.15. Okay, so the question asked how much more is investment B worth than investment A. So I need to subtract one from the other now, don't I? So 3713.15 subtract 3690. So that's £23.15 more, isn't it? £23.15. Now you notice I'm using a new emulator, or a new calculator this time. I've switched over to the Casio FX83 GTX, which is the new Casio model. Very nice piece of kit, and if you haven't got a calculator yet already for your exams, then this would be the one to go for, I think. I'll put a link to my shop in the description below, so you can click on that to find all my recommendations for calculators and revision guides and things for your GCSEs. Okay, let's move on. Question 8a. Show that the lines y equals 3x plus 7 and 2y minus 6x equals 8 are parallel. Do not use a graphical method. Okay. So two lines are parallel means that they are sharing the same gradient, isn't it? Their gradient is going to be the same. So the gradient of one is going to be the gradient of the other, and if you can show that is true, then they must be parallel. Now the first equation, y equals 3x plus 7, that's very easy to see the gradient because it's in the form y equals mx plus c. So if it's in the form y equals mx plus c, then you just really need to read out that number in front of the x, and that is going to be the gradient. So for equation for y equals 3x plus 7, so for y is equal to 3x plus 7, then our m1 I'm going to call it, is equal to 3. So the gradient of that equation is 3. Like I say, it's just this number here in front of x, the coefficient of x. Now the second equation I've been given is not in the form of y equals mx plus c. So we're going to have to rearrange it first. So starting with 2y minus 6x is equal to 8. Can I get it into the form y equals mx plus c? Yeah, I can. What I can do is just move that one over the equal sign, or add 6x to both sides. So that's going to give me 2y is equal to 6x plus 8. Still not quite in the right form. I'm going to have to divide both sides by 2. So I can get y is equal to something. So that's going to give me y is equal to, now 6x plus 8 over 2. I can divide the 2 into the 6x and into the 8. And that's going to give me 3x plus 4, like that. So now it is in the form y equals mx plus c. And you can see the gradient there is also 2. So I can say that m2 is also equal to 3. And therefore m1 equals m2. So they are parallel. Okay, done. Now, part B says, is the point minus 5 minus 6 above or below the line y is equal to 3x plus 7? Tick one box, above, below, or on the line. You must show your working. Again, not using a graphical method. Okay, so if I've got a line and I want to know whether my point is up here, on here, or below here, I think what I'm going to do is I'm going to take the x value from that coordinate and I'm going to substitute it into my equation and then see what I get. Okay, and then I can work out then, and then I can have a look at this value here, the minus 6, and see whether it's bigger or smaller than the value I get when I sub minus 5 into the equation. Okay, so let's do that then. So if y is equal to 3x plus 7, so when x equals minus 5, then that gives me y, which is equal to 3 lots of minus 5 plus 7. So 3 lots of minus 5 is minus 15. So that's minus 15 plus 7. And minus 15 plus 7 is going to be negative 8. Okay. So this then has a coordinate of minus 5, minus 8. That's the point that lies on the line. Lies on the line. Okay. So then imagine we've got our line that we know. We now know that this point here, when x is minus 5, is minus 8. Now, where is the point minus 5 minus 6? That's got to be more above it, isn't it, on the great scheme of things? Minus 5 minus 6. Negative 6 is more positive than negative 8. So it's going to lie above the line. Question 9. The cost of a ticket increases by 10% to £19.25. Work out the original cost. Okay. Now I always do my percentage questions using this triangle, final, original, multiplier. You just cover up the one that you want to find, and then that will give you the equation that you need. So here, final, well, I'm working backwards, aren't I? So I've been given the cost after the increase. So the final is 19.25. The original is what I'm trying to find, and the multiplier, it's a increase of 10%. So if I start with 100 and I add on 10, I've now got 110%, which as a multiplier is 1.1, isn't it? Okay, so I want the original, so let's cover that up, and that means my original is equal to final divided by multiplier. Original equals final divided by multiplier, which in this case is £19.25 divided by 1.1. This is a reverse percentage question, isn't it? If you do it a different way, 19.25 divided by 1.1 on my calculator comes out to be 17.5. This is in pounds and pence though, isn't it? So that is £17.50. I have to put that extra 0 on if it's money, otherwise you lose an accuracy mark. So the answer is £17.50. Question 10. The nth term of a sequence is 12n minus 2. Work out the numbers in the sequence that have 2 digits and are not prime. Okay, the nth term of a sequence is 12n minus 5. Work out the numbers in the sequence that have 2 digits and are not prime. Okay, so why don't we just try listing some of these numbers out. When n is 1, I'm going to have 12 lots of 1 minus 5. So 12, so n is 1. What we're going to get? 12 lots of 1 is 12. Take away 5 is 7 then, isn't it? And then when n is 2, so that's not got 2 digits, but when it's 2, it's 24 minus 5, which is 19. N is 3. 12 times 3 is 36 minus 5 is 31. 4 is 4 12s are 48. Subtract 5 is 43. 5 12s are 60. Subtract 5 is 55. 6 12s are 60. 72. Take away 5 is 67. 7 12s are 60, 72, 84. Take away 5 is 79. 8 12s are, well, so I suppose what we're doing, we're going up in 12s here. I'm getting a bit bored of doing it this way. Let's just go up in 12s. It probably works just as well. 79, 89, 91, and then 9 is going to be over 103. Okay, so that one's bust. So obviously 7 isn't one of them because it hasn't got 2 digits, and nor is 103. So what we've got left have 2 digits and are not prime. Okay, so let's cross out the prime numbers. 19 is prime. 31 is prime. 43 is 43 a prime number? I'm not sure. Let's have a think. Yeah, I think it is 40. I can't think of any factors of 43. I think that's prime. 55 isn't prime. That's the 511s, isn't it? And 67 is 67 prime? Yep, it is prime, and 79 I think is prime as well. So the only ones that are not prime are these two, then 55 and 91. So they're going to be my answer, 55 and 91. Question 11. I've been given A, B, and C as column vectors, and I need to work out what A plus B plus C is. Okay, so if I want to add these three vectors together, I'm going to be adding 6 minus 10. I'm going to be adding on -1, 2, and C, which is -4 over 7. So when I add column vectors like this, I'm going to be adding like the x components together. Those three are going to get added together, and I'm going to add the y components together, the -10, the 2, and the 7. Okay, so what does that give me then? 6 plus negative 1 is 5, plus negative 4 is 1. And negative 10 plus 2 is negative 8, plus 7 is negative 1. So that's going to give me 1, negative 1, 1, negative 1. Part B says, show that A plus 2C is parallel to B. Okay, now to show that two vectors are parallel, you need to show that one is a multiple of the other. Okay, so either equal to each other or as one is a multiple of the other one. Okay, so let's add A and 2C together first and find out what we've got. So what is A plus 2 lots of C? That's going to be my vector A, which is 6 minus 10. 6 minus 10. And I'm going to add on 2 lots of vector C, which is minus 4, 7. Okay. So this time I've got a scalar times a column vector. So both numbers in my vector get multiplied by 2. I'm going to do that one first, a bit like BidMaths. I'm going to do multiplication before I do addition. So I'm going to leave that one as it is to start with. And then 2 lots of minus 4, 7 is going to be 2 lots of minus 4, which is negative 8, and 2 lots of 7, which is 14. So I've got those, which I now need to add together. And just like last time, the 6 plus the negative 8 and the negative 10 plus the 14 is going to give me my resultant vector, which is minus 2. Negative 10 plus 14 is 4, negative 2, 4. Okay, now I need to show then that negative 2, 4 is a multiple of vector B. Now vector B was the vector negative 1, 2. Okay, now you'll notice that negative 2 and 4 are we've both got 2 as a factor. So I can factorize out 2 and write it as a scalar of that vector instead. So I can factorize out 2, which leaves me minus 1, 2 inside the bracket. And that, you'll notice, is the same as vector B. So I've got 2 lots of vector B. Okay, so I have shown that A plus 2C is equal to 2 lots of vector B, and therefore they are parallel. Okay. Question 12. We're told that pressure equals force divided by area, and we're given that a force of 40 newtons is applied to an area of 3.2 square meters. Work out the pressure. Give the units for your answer. Okay, so pressure is force over area. Now the force is 40 and the area is 3.2. So putting that into the calculator, 40 divided by 3.2, that gives me an answer of 12.5. 12.5 at 12.5 watt. I'm taking newtons and I'm dividing it by square meters. So then my unit is going to be newtons per square meter. Newtons per meter squared. You can write it like that, or you can write it with index notation. So you can also say that that's Newton meters to the minus 2. It's an alternative way of writing that same unit. Either one of those is fine. Question 13. Tick all of the statements that are true for any rhombus. Okay, let's just quickly draw a rhombus so we can have a look at it. So a rhombus is a bit like a pushed over square or a diamond. It's another way of thinking about it. So what are its properties? Are the diagonals lines of symmetry? Okay, so if I was to draw the diagonals on this, which is one going that way and one going that way, are they lines of symmetry? Well, you can see clearly that they are, so I'm going to tick that. Do the diagonals bisect each other? Does this line get cut in half by this line? Yes, it does. Are the diagonals perpendicular? A bit harder to see from my kind of wonky diagram, but yes, they are. Are the diagonals equal in length? No, they're not. One is longer than the other. So it's just those top three that we need to tick. Question 14. Draw the graph of y is equal to 0.8x for values of x from 0 to 6. Okay, now you should recognize this graph type. You kind of need to know quite a few different types of graphs. Now this one you should recognize as an exponential curve. Normally exponential curves look like this. Okay, but this one has got a number which is less than 1. It's a fraction. So it's going to look the other way around. It's going to look more like this. Okay, that's what is going to happen to this one. Having an idea of what your graph is going to look like before you draw it is definitely of a help. Okay, now let's think of the values involved here. 0.8 to the power of x. If x is 0, then I'm raising 0.8 to the power of 0, and anything raised to the 0 is 1. 0.8 to the power of 1, that's just going to be 0.8. 0.8 squared, I can still do that one in my head, 0.64. 0.8 cubed, do you know the cube of 0.8? 0.8 to the power of 3 is 0.512. 0.8 to the power of 4 is 0.4096. To the power of 5, 0.8 to the power of 5 make that 0.32768. I'm just going to round that off to 0.328, I think. And then finally 0.6, so 0.8 to the power of 6. I'm getting 0.262 for that. So you can see they're generally getting closer and closer to 0 as x increases. So I'm going to plot this then. Quite a big scale for y. Starts at 1 at the top there, look. So when x is 0, y is 1. Let's just zoom out a bit so I can see everything. My values and my graph. A bit more. So when x is 0, y is 1. It's that point up there. When x is 1, y is 0.8. There. When x is 2, y is 0.64. So each one of these little squares is going to be 0.02, isn't it? So 0.64 is going to be there. 0.512 for the next one. 5152, so it's going to be halfway up that square there. 0.4091, which was about 0.41. 0.41 there. 0.328, 0.33 is pretty close. It's there. And 0.262. 262, about there. Okay, you can see they're kind of forming a gentle curve. I'm going to join these all up with a smooth curve passing through each of my points. Okay, so it looks a bit like what I was expecting it to look like, so I'm quite happy with that. They're all kind of lying in a kind of curved shape. So I think we're done. Question 15. Amy has X beads. Billy has 3 more beads than Amy. Carly has 4 times as many beads as Billy. Circle the expression for the number of beads that Carly has. So Amy's got X beads. Billy has 3 more beads than Amy. So he's got X plus 3 then, isn't he? He's got X plus 3 beads. And Carly has 4 times as many beads as Billy. So she's going to have 4 lots of X plus 3. So it's that one there, isn't it? Question 16. Two straight lines intersect at a point A. It's there, look. Circle the coordinates of A. Okay, so we've got the graph y equals minus 4x, and we've got the line y is equal to 3. Okay, so the point there then is going to have the same y coordinate. It's going to have a coordinate of y is equal to 3. So it's something, comma, 3. So we need to know what the x coordinate is when y is equal to 3. So if y is equal to minus 4x, and we know that y is equal to 3, then we've got 3 is equal to minus 4x. Cross multiplying that minus 4 to the other side, I'm going to get x is equal to, well, it's going to be minus 3/4 then, isn't it? Okay, so x is minus 3/4, and y is 3, so my coordinates of A then are going to be minus 3/4, comma 3, which is, which one's that? It's that one there. Oh, struggled to spot it then for some reason. It's that one. Question 17. Here are two methods to make a 4-digit code. Codes can have repeated digits. Method A. For the first 2 digits, use an odd number between 30 and 100. For the last 2 digits, use a multiple of 11. And we've got method B, which says use 4 digits in the order even, odd, even, odd. Do not use the digit 0. Right, which method gives the greater number of possible codes? You must show your working. Well, that's an interesting question. Not seen one like this before. Let's have a look at method A to start with. Okay, so method A says the first 2 digits use an odd number between 30 and 100. So, odd numbers between 30 and 100. Our numbers lie between 30 and 100, and they've got to be odd numbers. So I've got the numbers, what could they be? They could be 31, 33, 35, 37, or 39. So there are kind of 1, 2, 3, 4, 5 odd numbers starting with a 3. Or it could be 41, 43, 45, and so on, up to 49. And then there'd be 51, and so on, up to 59. And that goes down to 99, doesn't it? So I've got 5 numbers in the 30s, 5 numbers in the 40s, 5 numbers in the 50s. So what's that? How many rows have I got altogether? So 30 up to 90, 3, 4, 5, 6, 7, 8, 9. So I've got 7 rows, haven't I? So then that means I've got 5 times 7, I've got 35 possibilities. 35 possible numbers between 30 and 100. So for the first 2 digits, use an odd number between 30 and 100. I'm going to have 35 possible choices for those 2 numbers. And then the last 2 digits use a multiple of 11. Okay, so the multiples of 11 well, they're 11, 22, 33, and so on up to 99, and aren't they? Our 2-digit numbers, which are multiples of 11. So there are 9 of those, 9 possible. Okay, so our first 2 digits use an odd number between 30 and 100. That's our 35 possible numbers for the first 2 digits, and our 9 possible numbers for the last 2 digits, give me a total of 35 times 9, which is 315 possible numbers using method A. Now method B, what have we got here then? So use 4 digits in order, even, odd, do not use the digit 0. Okay, so what are my choices? Even, odd. For an even number, I have got 2, 4, 6, or 8, so that's 4 choices. And for my odd number, I can have 1, 3, 5, 7, or a 9. So that's 5 choices. So then my total choices of even, odd, is going to be 4 choices, 5 choices, 4 choices, 5 choices. And if I multiply those all together, 4 times 5 times 4 times 5, 4 times 5 times 4 times 5, that comes out to be 400 possible solutions. So what was the question? Which method gives the greater number of possible codes? It's going to be method B. Question 18. Show that for x not equal to 0, x plus 4 divided by 3x minus 5 over 2x can be written in the form ax plus b over cx, where a, b, c are integers. Now don't worry too much about this bit. They have to put that in there, otherwise you're going to get division by 0, aren't you? Because I've got x plus 4 divided by 3 lots of 0, which if you've ever typed in division by 0 into your calculator, know is undefined. So that is all just really excluding that as a possible solution, just so that you're not dividing through by 0. Right, so what we want to do is we want to take these two fractions and put them over a common denominator then, don't we? Now normally with fraction subtraction, that's what you do. You would take your two denominators, you would find a common denominator, and then scale up your numerators accordingly. And we're going to do the same thing here. So I've got x plus 4 over 3x minus 5 over 2x. And we need to find a common denominator. So I've got 3x and 2x. So what's common? Well, they've both got x in it, so I can have x as part of my common denominator. And I've got the numbers 3 and 2, and so the lowest common multiple of 3 and 2 is going to be 6. So I'm going to use 6x then as a common denominator. So 3x goes into 6x twice, so I'm going to multiply up this one by a factor of 2 then, aren't I? So I'm going to get 2 lots of x plus 4, subtract, and my 2x goes into 6x 3 times, so I'm going to multiply this one up by a factor of 3. So that's going to be 3 lots of 5. Multiplying out the brackets on the top, 2x plus 2 lots of x plus 4 is 2x plus 8. Don't forget to multiply the 4 by 2. Minus 15 all over 6x. So that's going to be 2x. 8 take away 15 is minus 7, isn't it? So there we go, 2x minus 7 over 6x. So that is of the form ax plus b over cx, where a is 2, b is minus 7, and c is 6. So that is all fine. Question 19, the equation of a straight line is 3x plus 2y is equal to 24. Circle the point where the line crosses the x-axis. Okay, so our line crosses the x-axis when y is equal to 0. Okay, that's when it crosses the x-axis. So we need to sub in y is 0 into this expression and solve for x, basically. So if I've got 3x plus 2 lots of 0 is equal to 24, then, well, 2 lots of 0 is just 0, so I'm just going to get 3x is 24. X is equal to then 24 divided by 3, which is 8. So it's going to pass through at 8, 0. That one. Question 20. All dimensions are in centimeters. And we've got a triangle here, right angle triangle with sides x, 7x and 10y. And we need to use Pythagoras theorem to work out the exact value of x over y. Fun times. Okay, so what does Pythagoras theorem state? Pythagoras theorem says c squared is equal to a squared plus b squared, where c is the longest side and a and b are the other two sides of a right angle triangle. Okay, so here c is 10y, isn't it? And a can be x and b can be 7x. So we're going to sub those values in and see what we get. So 10y squared is equal to x squared plus 7x squared. Okay, so then just removing the brackets, 10y all squared, well that's 100y, x squared is just x squared, and 7x all squared is 49x squared. Oh, sorry, I missed a square off there. So 100y squared is equal to x squared plus 49x squared. In other words, I've got 100y squared is equal to 50x squared. So we want x over y. So let's cross multiply then. Let's divide by 50 and by y squared. And that will give me 100 over 50 is equal to x squared over y squared. Getting close. So 100 over 50 is equal to 2. So 2 is equal to x squared over y squared. But I want to take the square root of this. So x over y then is going to be the square root then of 2. Be the positive and negative square root of 2, won't it? Okay. So work out, well, it can't be the negative one because it doesn't make sense in terms of this problem. So it can only really be the positive solution. So I'm just going to leave it as the positive one actually. So x over y then is root 2. Question 21. We are told that the mass of an ornament is m grams. The height of the ornament is h centimeters. M is directly proportional to the cube of h, and m is equal to 1600 when h is equal to 8. Work out the equation connecting m and h. Okay, so we've got a straightforward question here in proportionality. We are given the type of proportion here. M is directly proportional to the cube of h. So we can say m little fishy or is proportional to h cubed. Okay, so that's our proportionality. Then we're going to take the little fishy symbol out and rewrite it as m is equal to k lots of h cubed, where our k is our constant of proportionality. So once we've got it into that form, they normally give us a pair of values that go together here to work out what k is, work out that constant of proportionality. So we're going to sub in those two values and work out k next. So when m equals 1600, h is equal to 8, that tells me that 1600 is equal to k times 8 cubed. Subbing in. And then, so what is 8 cubed? So k is going to be 1600 divided by the cube of 8. So k then is going to be 1600 divided by 8 cubed. 8 cubed is 512, isn't it? 512. Okay, does that simplify? Let's just try that. 1600 divided by 512. That simplifies down to 25 over 8. So k is equal to 25 over 8. Okay, so what is the equation then connecting m and h? Then m is going to be 25 h cubed over 8. Okay, all done. Now part B wants us to go on and use our newfound equation, work out the mass of an ornament of height 12 centimeters. So when h is equal to 12, then m is going to be 25 lots of 12 cubed divided by 8. So tapping that into the calculator. 25 times 12 cubed equals, divide by 8 equals 5,400. 5,400, that's my answer. Question 22. A, B and C are points on a circle. DCB is a straight line. PAQ is a tangent to the circle. All that information is already on the diagram. I've got nothing extra to add to it. So Sam is trying to work out the size of angle M. Here is his method, or his working. Angle ACB is 56 degrees. Angles in the same segment are equal. M equals 180 minus 56. Angles at a point on a straight line add up to 180. M is equal to 124. Make a criticism of his working. Okay. Well, how would I work out this? I would note the fact that that angle down there is 56 and use it to work out this angle up here. Now this angle is also going to be 56 because these two angles, this one here and this one here, are equal because of the alternate segment theorem. The angle in the alternate segment is equal to the angle between that chord and the tangent. And then I've got two angles that lie on a straight line. So this angle here plus the 56 is going to be 180. So then M is going to be 180 minus 56 because of angles on a straight line, which gives me 124 degrees. Okay, so I'm agreeing that ACB is 56. I'm agreeing that M is 180 minus 56. And I'm also agreeing that M is equal to 124. So that is all fine. What is not fine though is this statement here. Angles in the same segment are equal. Now that is a true thing. Angles in the same segment are equal, but that's not what we've got here. Here we've got the alternate segment theorem. Angles in the same segment is this rule where you've got two angles drawn off the same chord. That is angles in the same segment being equal. That is not the rule we've got here. So my criticism is, so what's his name? Sam. Sam should have used the alternate segment theorem, which he didn't do. Question 23. A sequence of numbers is formed by the iterative process. Un plus 1 is equal to 3 over un plus 1, where u1 is equal to 4. Work out the values of u2 and u3. Right, just before we get going, just note that this un plus 1 is not the same thing as this thing here, un plus 1. This un plus 1 is 3 divided by un plus 1. Okay, so we take our previous value un, we add 1 to it, and we divide 3 by that number, and that will give us our new value un plus 1. So if I've got u1 is equal to 4, then u2, the next value, is going to be 3 divided by u1, 4, plus 1. Okay, so my un here is 4, u1, and my u2 is my un plus 1. Okay, so I've got 3 over 4 plus 1, which counts, well, it simplifies down to 3/5. And then my u3 then, my third term, is going to be 3 divided by my second term, 3/5 plus 1. Now that is equal to, well, what's 3/5 plus 1? 1 is 5/5. So 3/5 plus 5/5 is 8/5. So I've got 3 divided by 8/5. Now dividing by a fraction is the same as multiplying by the flipped fraction. So flipping over 8/5 to 5/8 and multiplying instead, that tells me that 3 times 5/8 is 15 over 8. So my u2 term then is 3 over 5, 3/5, and my u3 term is 15 over 8. Question 24. The speed time graph shows 20 seconds of a car journey. Harry wants to estimate the distance the car travels in this time. He uses a triangle and a trapezium as shown to estimate the area under the graph. Okay, so we've got a speed time graph, and you should know that the area under a speed time graph is the distance traveled, and we need to complete Harry's method to estimate the distance the car travels. So basically we're going to find the area of these two shapes and use it as an approximation as the total area or the total distance travelled. Okay, so how do I find the area of a triangle? Area of a triangle is a half base times height. So my base here is this distance, which is 10, and my height is this distance, which is 20. So then my area is going to be a half times the base, which is 10, times the height, which is 20. So half 10 times 20, well, half of 20 is 10, and 10 times 10 is 100. So that's 100 meters. Okay, so that's the triangle. Now for a trapezium, area is equal to a half a plus b times h, where a and b are your parallel sides. So basically you're averaging out your two parallel sides and you're multiplying by the distance between them. So I already know a, it's that 20. B is going to be this length here, isn't it, which is 30. And then the distance between them is going to be my h value. Distance between 10 and 20 is 10. Okay, so my area here is going to be a half 20 plus 30 times by 10. 20 plus 30 is 50. Half of 50 is 25, and 25 times 10 is 250. Okay, so my total area under curve is going to be the area of the triangle plus the area of the trapezium, which is 100 plus 250, which is 350, and the units must be what we've got, meters per second and seconds, so that must come out to be meters then. 350 meters. Question 24b. For this journey, which of these is true for Harry's method? Tick one box. Okay, it works out as an overestimate of the distance. It works out as an underestimate of the distance. It could work out as an overestimate or an underestimate of the distance. Okay, well, let's have a look at the method. Go away, silly thing. All right, so I've got a triangle here which is pretty much spot on, but my trapezium, look, when I calculate the trapezium, I'm not calculating this bit up here. So the true area under the graph is a little bit bigger than the area that I've calculated. So what I've calculated, this 350, is going to be an underestimation because I haven't calculated that bit there and included it in my answer. So it's an underestimate of the distance. Question 25. ABCDEF is a triangular prism which represents part of a hill. ABCF is the horizontal rectangular base. D is vertically above C. Okay, so it's a right angle triangular prism then, isn't it? So work out the height of CD. So we need to find this distance here then, don't we? Okay, which is the height of this triangle. Now I know that this distance is 500 and this is 6 degrees. So I could use just normal trigonometry, can't I? Okay, so just taking out triangle, what is it? BCD, in triangle BCD. Okay, let's just draw a quick sketch of that down here. That's a right angle. This was 6. This was, well, this is the point B, isn't it? This is the point C, and this is the point D. And we know that this is 500. So we want CD, don't we? So CD is the opposite in this right angle triangle. 500 is the adjacent. So according to SOHCAHTOA, the tangent of an angle is equal to its opposite divided by its adjacent. So I'm going to use tan theta equals op over adj. Okay, so I want the opposite, and I know the adjacent, and I know the angle. So I've got tan 6 equals the opposite, which is what I want to find, CD, divided by the adjacent, which is 500, which means that CD is equal to 500 tan 6. So time to reach for the calculator. 500 tan 6 equals 52.6 to 3 significant figures. So I'm going to write that down as 52.6 meters. Okay, does that look about right? Yeah, it does. If that's 500 meters, it's about a tenth. That looks about right for that sort of angle. Right, so what does part B says? Jamil walks in a straight line from A to D. So he's walking up the hill from there to there. Let's just draw that line in so I know what I'm talking about. Okay, from there to there then, isn't it? So he's walking up the grassy hill up to D. Okay, work out the size of the angle DAC. Okay, so I'm going to add another line in here. We're talking about this triangle here, aren't we? So I'm going to draw that line in as well. Oops. Now again, this is a right angle triangle. This angle in this corner here is also going to be a right angle, isn't it? Because it's still the line CD, which is vertically above D is still vertically above D, so it's still going to be a right angle in that corner. What do I know about it? Don't know a lot right now, do we? I want to work out the size of angle DAC. I want to find this angle here. I know DC. I just found it. It was 52.6, wasn't it? So I know that side is 52.6, roughly. So I need another thing. If I want to work out this angle here, I'm going to have to find another thing in this triangle. Okay? Well, I can see that this length AC is the hypotenuse of the triangle ABC. So having a look at this triangle here, ABC, this is a right angle triangle again. The right angle is down here, and AC is the hypotenuse of that. So I can use Pythagoras theorem in that triangle to find AC. And once I know AC, I can use AC and CD to find the angle. So let's do that then. So I'm going to say in triangle ABC, I'm just going to quickly draw that triangle. So ABC, that's 400, that's 500, and that's my right angle. So I'm going to use C squared equals A squared plus B squared, Pythagoras theorem, which means I've got the length AC squared, and that's equal to 400 squared plus 500 squared. What's that then? 400 squared is 660,000, and 500 squared is 250,000. And that all together then is 410,000. So then AC is going to be the root of that then, isn't it? So root 410,000, that's 640.3. Okay. So AC is roughly 640.3. So now I'm going to switch triangles. I'm going to now switch to this triangle, the ACD triangle, that one there. Can you see that? So in triangle ACD, so that's my long thin triangle. This is theta. I just worked out the bottom line, didn't I, which was 640.3. That's a C, and I know that CD from before was 52.6. Okay, so now I can work out theta. I'm going to use tan theta equals opposite over adjacent. So I've got 52.6 divided by 640.3. So tapping that into the calculator, 52.6 divided by my previous answer, that's 0.08 something, and then I'm going to do shift tan answer of that to find the inverse tangent. I get an angle of 4.696, which I'm going to round off to 4.7 degrees. So theta is equal to about 4.7 degrees. 4.7. I was calculating with 3 and 4 significant figures, so it's only fair to drop down to 2 now. Stating any more accurate than that would be a bit of an overstatement of my accuracy. So 4.7 I think is good enough. Advertisement break. Hopefully you are able to use this past paper to identify any topics that you still need to focus on for your exams. It's best if you do some focused revision around these topics between past papers, and this series of videos will help you do just that. They are based on the AQA topic tests, including key topics like trigonometry, surds, indices, and a whole lot more. Click on the card above to go to the playlist. I'm adding to this collection all of the time, so if the topic is you're looking for is not yet covered, it soon will be. So subscribe below to make sure you don't miss out on any of these uploads. Right, back to the maths. Question 26. The histogram shows information about the speed of cars as they pass a checkpoint. The scale on the frequency density axis is missing. Yes, it is. The histogram shows information for about 480 cars. First off, we need to know how many cars the first bar represents. Okay, so we know altogether this histogram represents 480 cars. Now, it's the area of a histogram that is proportional to the frequency. So the area of these 3 bars must represent 480 cars. So whatever this scale is along the side here, altogether then that is going to represent 480 cars. Now we don't know what the numbers on this scale will be yet, so let's just call that representing 8x units as an example. So one of those distances is x. So that makes the area of this first bar, I've got 1, 2, 3, 4, it's of a height 5x, isn't it? And the base of it is 5, 10, 15. So this is going to have an area of 15 times 5x, which is 75x. Okay, now the next bar along is of a height, what's that, 6.6. That's 6.6x times a width of 5, which is a total of 6.6 times 5, 33x. So that's going to be 33x. And this last one is 0.8x times, what's that, 5, 10, 15 times 15. And 0.8 times 15 is, it's got to be 12x. Okay, so what's that all together then? I've got 75x, 33x, and 12x, which adds up to 5, 8, 10. Carry 1, 2, 5. It's 120, isn't it? 120x. So the whole of that graph then is 120x, and 120x is going to have to be equal to 480, making x 480 divided by 120, which is 4. Okay, so x is 4, and that means that height there on the frequency density must be a 4, 8, 12, 16, 20, 24, 28. Okay, so now we know the frequency density, the scale. We can now work out how many cars does the first bar represent. So the first bar is now of a frequency density height of 20 and a baseline of 15. So frequency is going to be 20 times 15, which is 300, isn't it? So that's 300. So 300 cars. Does that look about right? It's the bulk of the cars, isn't it? And there's 480 altogether. 300 out of 480 looks about right to me. Right, cars with a speed greater than 40 miles per hour are over the speed limit. Use the histogram to estimate the number of cars that are over the speed limit. Okay, so 40 miles an hour is here then, isn't it? So the cars that are over the speed limit would be the ones represented by this part of the histogram. Now it's going to be an estimate because actually we don't know the speed of the cars in this area. We just know it was between 35 and 50. But we're going to use this as an approximation. So this is a little rectangle with a baseline between 40 and 50, so a base of 10 and a height of, well, each one of these scale now is 4, aren't they? So we've got 4/5 of 4. 4/5 of 4? So what's 4/5 of 4 then? Well, that's just 16 over 4, 16 over 5 then, isn't it? Which is just, it's like 3 1/5. I'm just going to leave it as 16 over 5 for now. So this is going to have a height of 16 over 5 and a base of 10. So its area is going to be 16 over 5 times 10. So 16 over 5, which was the height of the bar, times 10, which is the baseline of the bar, is going to give me 160 over 5, which is 5s into 160 go 32 times, doesn't it? So I'm going to estimate that there are 32 cars. Question 27. A bag contains 30 discs. 10 are red and 20 are blue. One disc is taken out at random and replaced by 2 of the other colour. Another disc is then taken out at random and replaced by 2 of the other colour. Another disc is then taken out at random. Oh, what a fun game. Work out the probability that all 3 discs are taken out are red. Okay, so we're going to have quite a complex tree diagram here, aren't we? If I was going to draw this as a tree diagram, I'd have my first selection, second selection, third selection. Okay, so it's like a 3-level tree diagram. So if this is red, let's do red and blue. Red, blue, red, blue, red, blue, red, blue, red, blue, red, blue, red, blue. Now we don't have to work out all of the values for this. We're only really interested in one of the roots, aren't we? We're interested in the probability that all 3 discs taken out are red. So we're interested in following this line of the probability tree up. Okay, so let's see if we can work out the probabilities of these branches rather than the whole thing. So one disc is taken out at random and replaced by 2 of the other colour. So to start off with, we had 10 red and 20 blue. So the probability of selecting a red one is going to be 10 out of 30. So 30 discs altogether, 10 of which are red, 10 out of 30. Okay, now in the second selection, that means that if we went this way, we've now got 9 red discs and 20 blue discs, but we're going to put in 2 of the other colors now. So I'm going to have, at this point here, I'm going to have 9 red and 22 blue. So that would be 31 discs altogether, of which 9 are red. So the chance of picking another red one is going to now be 9 out of 31. Okay. And then same thing again then. So then if I want to then, if I picked a second red, then I'm going to now have 8 reds, and I'm going to put another 2 blue in. So altogether now I've got 24 blue and 8 reds. So my chance of picking a third red is going to be 8 out of 8 plus 24 is 32, isn't it? It's going to be 8 out of 32 going in that direction. So the probability then of picking red, red, red is going to be those 3 numbers multiplied together. So it's going to be probability of red, red, red is going to be 10 out of 30 multiplied by 9 out of 31 times 8 out of 32. What's that? 10 times 9 times 8 is 720 over 30 times 31 times 32, 29760. 29760. Does that cancel down? Don't really need to. I think that's fine. I'm just going to leave it like that, I think. Just remember that in probability questions, you never ever get any extra credit for cancelling down to a fraction in its lowest term. So all you can possibly do is risk the chance of losing marks. So I just tend to leave it as what it is I've given in whatever form it first arrives, and not worry about cancelling. Just wanted to take a few seconds out to talk about my Patreon page, which you can find at patreon.com/Mr. Tompkins EdTech. On here you can gain access to exclusive content, including early access to my past paper walkthroughs. So if you like my content, definitely worth checking that out. Also, if you become a Pythagorean patron, you get a special shout out in every video. So check it out. Back to the maths. Question 28. P is a point on the circle with the equation x squared plus y squared is 80. P has an x coordinate of 4 and is below the x-axis. Okay, so we know that that is 4 comma something. I'm just going to call it 4y for now. Okay, work out the equation of the tangent to the circle at P. Okay, so we need to find the equation of this line. Now, in order to find the equation of a line, we need to know 2 things. Either the 1 point on the line and its gradient, or we need to know 2 points on the line. Now, at the moment, we've got part of 1 coordinate. We know that the x coordinate is 4. Now we should be able to use the equation of the circle to find this value here of y. We're just subbing x into it, and we'll work out what the value of y is. So that will give us 1 point on the line. Now how are we going to find the second point or the gradient? Well, if I draw this line in, which is the radius of the circle, oops, then you should know from the properties of a circle that a radius joins a tangent at 90 degrees. So we do know 2 points on this line. We know that that one is 0, 0. And once we find y, we'll have a second point on this line. So that is enough information to find the gradient of the radius drawn at the point of contact, and then we can use the fact that that radius and this tangent are perpendicular to find the tangent gradient, and then we should be able to find its equation. So quite long, but let's just get crack on and let's get it done. So the first thing we need to know is that y coordinate of P. So at P, when x equals 4, then y then is going to be, well, the equation of the circle is x squared plus y squared is equal to 80 then, isn't it? So we're going to get 4 squared plus y squared equals 80. So 4 squared is 16, so then y squared then is going to be 80 minus 16, it's going to be 64, giving you values of y as plus or minus 8. So if we have a look at our graph, you can see actually there are going to be 2 points on this curve. You're going to have one up here, which is going to be at 4, and that's going to be the plus 8. And then this one down here then is going to be our minus 8 then, isn't it? Okay, so we've got our point on our line, 1 point on our yellow line, 4 minus 8, so we're getting there. So the next thing then is to find the gradient of our radius. So this line here, let's find the gradient of that. Now we know 2 points in that. We've got 0, 0, and now we've got the point 4 minus 8. So we can easily find the gradient of that. So on the line OP, it's a good idea to put little sentences explaining what you're doing. So our gradient M, we'll call it M1 because we're going to have 2 gradients. Our gradient M1 is going to be, do you know the formula for it? It's y2 minus y1 over x2 minus x1, where x1, y1 is your first coordinate and x2, y2 is your second coordinate. So my first coordinate, x1, y1, is going to be this one up here, and this is going to be my x2, y2. Okay, so subbing that in carefully, I'm going to get y2, which is minus 8, subtract 0, divided by x2, which is 4, subtract 0, is what then? So negative 8 divided by 4, which gives me a gradient of negative 2. So my line OP, my radius, has a gradient of negative 2. And I'm going to call this point up here T, so I can refer to it as PT. So OP and PT are perpendicular. So a shortcut of way of writing perpendicular. It's like a perpendicular sign with AR written on the end. So OP and PT are perpendicular. So M2, the gradient of our line PT, is going to be minus 1 over M1, which is the negative reciprocal of negative 2, which is positive a half. So that tells me that the gradient of my tangent then is going to be a half. So tangent PT is of the form then y is equal to a half x plus c, because I know the gradient now is a half. All I need to do now is to find the y-intercept, and to find the y-intercept I could just sub in my point that I know. I know that it passes through the point 4 minus 8, so subbing that into the equation, so minus 8 then is going to be equal to a half of 4 plus c. Okay, well a half of 4 is 2, and subtracting 2 from both sides will tell me that c is equal to negative 10. Okay, so then my equation of my tangent is going to be y is a half x subtract 10, because I just found c was 10. And that's it. So it's quite a long question, but the skills you should all know fully well. How to sub into an equation, finding the gradient of a line, knowing that two lines are perpendicular to each other, how to find the gradient, and then finding the equation of a line given a gradient and a point on the line. Okay, all done. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.